Hello, I hope everyone can hear me. Testing, 1, 2, 3. Please just write yes. Please just write yes if you can hear me in the hello everyone. I hope everybody is set. We're about to start. So come back to this 14 days training. You're all welcome back. So we are now going to start the full training of the program about geophysical data analysis. We'll be looking at magnetic data, radiometric data, and Landsat data. So integrate magnetic gravity Landsat, gravity, Landsat magnetic. There are so many combinations that areas. That's why it's important. And also there is a chat box in case you don't understand. You try it so that I can go back to it and then look at doing. It's going to be a 14 days training. It's going to be completely free. Then again, loads, of course, we're going to be using this data which you can go to this link and download. You can check the description of the video where you can download this one. It is there in the description of this live video, that program. Okay. This is where we get the gravity data. Unfortunately, I don't have the land ground-based gravity. We're going to see where we're going to get this data, gravity. This for the DM data, we can get it from the Art Explorer and any part of your work you want to do. Then you can also support me so that I'll keep on producing throughout. No matter how little it is, you can. This is my email, which you can able to get in touch with me. And which you can see, this is my email, and these are some of the works that we're going to be used. Of course, we have the magnetic data, the rest. Then if I go to the desktop, when you download, this is what you get, training data. Then when you open this training data, you have the gravity, data, how it's acquired. The magnetic, of course, this one is not a link. This one is a paid, it's purchased, so I'll give you it free of charge. It's also in the download link. It's aeromagnetic, and also this is aeroradiometric data for different sheets, for potassium, thorium, uranium, for each of the sheets. Sheet 204, you have potassium. So those are the things we look at. Then this is the data sheet of where we get it. Of course, the study area is Nigeria. So of course, the study area is Nigeria. As you can see, this is Nigeria. One is, I think, 2004. No, 203, 204, 25. This. So this part of the area, we have a aeromagnetic data covering this area. We also have the also going to acquire the gravity data and also the Landsat data, which you are going to see and how we are going to integrate them. So this is the 4 part of the area which we are going to have. Also, there are some other folders which you will see. Of course, this is the geology. Of course, for your countries, you can get it from anywhere you want. It is a high resolution, is a very high resolution data with all the description. It is there. So I give it free of charge. Also the lineament map, which is also important, which you're also going to be seeing. All these are the things that you required for your study area. But for Nigeria, you don't need to have everything is provided there for you to download free of charge. Also, you can zoom in, zoom out, you see the faults. Yes. So this is where we'll be taking our lineament from right from here. And then see how we get above this in a moment. Then other, which I can say is 204 from the Nigeria Geological Survey Agency, is made available here to carry out our research. Now, back to the chat. So if there is anybody that wants question, I hope the audio is cleared. I see, thanks for the video, Mustafa Ali. I'm very grateful for that. series of softwares that we are going to be using. Oasis Montaj software. This is one I'm using. I help about which is version 8.4 standard. Of course, we'll be using Sulfur in the Sulfur software, which is also free software that you can download. GIS to drawing beautiful. We'll be using also validations and able to get our study area in our study. The MV software, which will be mostly be the remote sensing, which is the, of course, not the last, we have Excel. Excel is also, you know, many tricks. Then we have a notepad. I think there's a notepad to taking down our notes. To have acquire of all the. So these data are very, very able to know all the softwares that we. So that's the essence of this course, how to link, use Oasis Montaj as a software, everything with it. Because of this thing, softwares and do a lot of stuff here and there. So let's start first. What we are going to do today is all those data, arrange them, area, get the area map, get the lineament map, so that we'll focus. Do it. Okay. Somebody asks how to get the MV software. Now require to find out how you can get your own copy. Unfortunately, I don't have one. Yeah, I don't have. Because the training is going to be safe. Like I said, it's going to be safe. The crowd, of course, is going to be safe. But of course, that which you can watch the replay back and now on the desktop, I created a folder of Nigeria. We have data. I've mentioned when you download it, which I've told you. Then these resources, let's go back to the resources. Of course, so this is a page, the link I tell you why you can support. You can able to support me. So there are a lot of other people that have supported my work so that I can produce more content. The choice is yours. Then this software, which is where we get the National Center for Geological Art. We have Art Explorer, which you need to create where we will be using to get our Landsat data. Geoafric.gafrica, in order to get the so you can able to produce your map, which are not. We need this data, which also part data, which you also can get from this site. My YouTube channel, which you can subscribe, and then tomorrow, which we're going to continue. Note off. All these things are things you need to use. It is there in the description. Now, really we open this folder we created. Let's go to this. Under Montaj, OSM project. Create a folder, then also create a folder in Google, because it's going to be a complete QGIS project. Will be used also the software when we come to geothermal energy. When we come to remote sensing, MV project. Project and Oasis Montaj. So this is what we need to have. Of course, what we do, we have. What I'll do, I will just under the, of course, we can bring the area under the folder, which is data. Our own data. This, we need the gravity 3 data, all control, there you go back. So let's save the data. Let's see whether there's anybody have question to ask. Okay, I hope for the next let's see, let's go back to the folder. Under this, I also like to have images. Where I'll put my images be exported. Also need to have maps. Also need to have models. Also need to have my profiles. Also modeling. So, I'm able to bring out our data, get the gravity data, then see how it comes about. So, and that is so what we're going to now move on to see how we are going to continue doing it. I hope if you have a question, you can ask. Is there anybody? I hope everything is cleared. To link them together, bring everything, the gravity and the Landsat and the rest. I've opened the Oasis Montaj, which we already know. All we need to come down to this particular man and create a project. Under this, we go to desktop and there's locate our main file, which is Quadra State. Inside, we have to organize your work. Then on this one, I'll call the complete work of Oasis Montaj free training safe. Now it has been saved, of course. This program to work with all of these things, open this, maintenance, and the rest, which is also going to look at this, import, export, properties, metadata. Things we look at, import the ArcGIS, MSD, the coordinate, look at all those things. All those things, grid and images, map tools, the rest, contour, and the rest, card tools. Okay. 3D, then we have the this, we don't need to new this thing, then we have some of the menus we can load. which we'll see when we come to analyze the magnetic data. Get first the magnetic and gravity here ready. They'll move back to the land site and then try to see how we get all those other data. Now, like I said, inside this, we have the data, and then we are going to import all of this. And of course, all of it, again, notwithstanding, let me open this folder again. Let me look for that data images, data sheet. So we're going to see this. Then now, let's go to the Oasis Montaj. A lot of things we're going to learn. First of all, we need to bring out our grids we have. We'll go to grids. This is the grid talk about. You right click on it. You have add grids. Now it has already put us into the project. We'll go to data. We have to magnetic. Then what you do, you click the first one. You hold down the shift button on your keyboard. You click this the 4 into it. And remember, the sheet you have, they're already graded to soft grade. If you see an error, you can come over here, click on file types, you switch to software in case you see an error. If it's being graded by software, right? But since it's being graded, you can leave it yourself. But in case there's an error, you can shift to software layout here, which you can see. Then you click on open. So that means there is no error. All the 4 are going to open. All are open. There you can see them. All you need to do to come to Windows, we close all this one we have. Then we'll click on this plus symbol. We have the 4, 1, 2, 3, 4. If we double click on this, it open up. We click on this. We're going to do a lot of things here. Okay, this is the first one. We click on this globe symbol to zoom to full map. This is the full map you see. You click on the other one, the second one. You click on this. Then you click on the third one. This. Then you click on this. Also zoom to this one. So these are the 4 we have. Then if you click on this grid, right click, you have other things you can remove from the project. So anytime you come back to it and do it, the properties, the metadata delete. You delete it is completely removed. Then let's look at the properties. When you look at the properties, you can see down here, the coordinate system is unknown. Take note of it, it's very unknown. That's one thing you need to know. Then if you look down to the status bar, as you move your pointer here down to the status bar, you see these large values. This shows you that this value are in projected system you see is unknown. So we need to start with 303 first. Push this into the database. We'll push this one to the all of them and produce our TMR. Let's take the 203 first. Then we'll come to grid and image, utilities, push this to a database. Then here the grid file is this one, 203. Then here you call it T203. Then the third channel, that is magnetic intensity, we'll call Z and click OK. That's going to be push them. Is there anybody have question to ask? Okay, I think there is nobody have question. So it is loading. Let's see whether it has finished loading. We'll open this one. Now we have databases. So we don't need this one. We'll right click, we'll remove from the project. Then we'll come to the second one. You double click on it. Utilities, save grid to database. Then you scroll to have 204 selected. Then you click on this, you edit it. Click remove from project. Let's come to 224. The same thing, grid and images, utilities, save grid to database. The data, we have many grids. In case it's only one grid, the similar process you can follow. That, then you have 224, then okay. Okay, so right click on this, remove from project. Okay, so now we'll come over. So click on this one, you come to create an image utilities. Save grid to database. Then this will give you 225. Then don't forget to select the last one. That's very important. As you put there, you remove it. 225, then click OK. Now we have them. Go on this, right click, remove from project. Then we'll go to this first one. Let's see whether that. Please, if anybody have a question to ask, you are free to ask a question if you want to. If you want to ask a question, then you are free. Then let's see. Now I have this 1, 2, 3, 4. So all the 4 databases. Then we'll take the first one, we right click. We have properties, metadata, delete. These properties, when we click on these properties, is unknown, as you can see. So we need to project it. We need to set it to the right coordinate system. Because this is in meters, you go to coordinates, then click on this one, coordinate system. Go back, make sure that this one is double click. Now it has become bold. That means it has been selected. It's coordinate system. Then this is change this. Then under this, go to projected. Then wait, then in Nigeria, this is, you type UTM, zone 32 degree north, 32 degree, you click OK. Now it's been projected, you can confirm it, right click, properties. Now you see it, UTM, zone 32 degree north, WGS 84. Then we'll go to the second one, coordinate system. Then if we select this one, it's going to automatically fill this for us. So which is going to automatically fill it for us. Which from there, we now going to right click properties. We have then coordinates, coordinate system, yeah. Projected is degree north, been selected. The one, then coordinate system. Then we set it to projected, then, which is automatically going to pick it up. Then click on file, project, always farm again, properties. That's okay. So now we're going to match those four. Look at the sheet. This is the sheet. This is 203, 204, 205. So what we're going to do, we'll start with 203, then we are going to append all these three to this, so that we are going to add these three to this one. And this, then you are going to add this to this. If you start with this, you add this, and from the left, then go right. Take this one, then you add these three to get this to 203. So how do you do it? We go to database tools. We have channel match database. So match database, of course, is T203. Then you select this from here. Set. Then double click on this three dot to that 203. Then now you hold your shift, click one, hold shift, click the last. So I see it's going to bring them in this format 204, 205, 224, 205. And lines, you say all lines. Channel, the same channel. So leave this one, no, then click OK. When we do that, side T03, match the two. For here, we need to say, replace existing data, we say append. Sorry, it's going to be append because we are going to append it to these other ones. When we click OK, we'll see, wait for some few seconds, up to a minute. Let's see whether there will be an error or not. You see an error occur. An attempt to add line this failed because the database this is full. Okay, so when you see error like this, you say okay. Then now you go back to then you go to database, then come to maintenance, then go to grow. We're going to increase the capacity. It's 203, open it, then yes. Before it was this, so I can set this one to this 1,800, I'll set it to 3,000. Maximum channels. Okay, then click OK. We have now expanded. It has grown it up. You can click on this, right click. You can see it. I think if you click on this more, you will see it up to 3,000. We have increased it to database tools, database utilities. Let's see whether there is somebody have question to ask. Is there anybody have? So any question? Will anybody have any question? So any questions? So let's move ahead. Let's see how we're going to match. In case you see that error, that's how we are going to match them. They'll go to database tool, database utilities, match databases. Now, we select this first one at 203, 204, 205, 206. We'll add it to 203. All lines. Now it's going to modify 203 and add all the other one, existing one to that one. So let's wait. Well, it is based on this, we can now get our gravity data, we can get our Landsat data, and also the topography data. Okay, so this is the way to, now you see it has modified. Let's go to T03. It has been modified. It has been increased. The size has actually been increased. We'll go to the data, go to this, go to Oasis Montaj project. Let's look for that 203. This is the one modified. You see the size almost 226 megabyte. 204 is 24. It has increased it. So that's why everything is in this one, you see. Now this is what click, remove. All this one, right click, remove. All this one, right. Thing we have, let's right click, properties. This is what we have. Match. So we have now something match, which now, based on this, now we are going to get to this GMI database, which is TO3. It's what we have been using. So this is what we have. Then we'll go to come here, right click, insert column. Like adding two columns, one for longitude. You put new, you right click on this, new. If you put long, okay, then right click on this, new, they call it lat. So, and this is what you have. Now, we need to convert from the X to longitude and Y to latitude. The coordinate now, new projected coordinate system. We have, click next. Being in projected first, confirmation, the next. As you can see, Y to latitude, then click next. Coordinate system, this is what we have, then click OK. Now use to get our gravity data, get our Lancer data, elevation model data. It's important to follow this step. From these other things we have, now you see the format is in degree, minutes, second. So click on this, right click, edit. Now change the format to normal, increases to 3 decimal place of decimal or 4 place of decimal. It's okay. Now it has changed. Right click, edit, format, normal, 3 places of decimal. So this is what we have. Now let's see whether somebody have question. So somebody is asking, what is the purpose of merging different? So like I said, they're going to be thing. We're not doing analysis here, so we'll try just to bring the grade we have. Of course, the reason why I only this one, we don't need to match. But the reason why we need money grades deeper and deeper into the earth. That is the but when you make it very less, you will able to get just like electrical resistance. Current electrode increases, then the depth of investigation also increases. To take note of, you see, even if you have only one area, fine, but going for the case where you can have some people can use up to 20 sheets, or you can do it. It's possible. How do you go about it? So this is the method of doing it. In case you have problem like this, you may not able to figure out that if you have more than one sheet, this fine. If you have only one, then this will just going to be the one you just follow this you can skip the issue of what? Match database. So I hope the question recorded. Also, we are going to, like I said, go to 14-day programs. So now from here, I need to open Notepad. Then I will come here. Then if you are using Windows 11, then open this. You can see it is now open into 11. Now what I'm going to do, I'll click on this 3 times. 1, 2, 6. Then you see this is the, now what are the area? Mean long. The mean long is 5. Mean lat. Mean lat. Max lat is, as you can see, is 5 points, which you can copy it from here. So that is 5 to 5.77. We are good. We can also save it to use format. And let's click on this, click 3, latitude, 1, 2, 3, right click, statistics. What we do, we just copy this one. Sorry. So I hope everybody can hear me now. So if yes, you can write yes if you can hear me very, very well. Now you see I have this I've got from my Oasis Montaj. Okay. Then I'll click file, then project save. Then let's go to this file. We need to come to this file, which I have. I will now Control C, save. Then I'll go to my Katsina state, Kwara state, project, data. Then I'll call it study area. So that you can come to this study area info. Okay, so this is what we have. Now we save it. We are coming back to this. Okay, so I hope everybody is now getting what I'm saying. Now let's come and grade our destiny. First, you can see the underline here is showing that the horizontal is projected X, the vertical is Y, and the third value is Z. So let's come to coordinate, grade and image grading. Then we have minimum curvature. Click on this. Then the channel to grid, which is the Z. That's what these two values automatically pick. Then the output channel, I like to call it TMI underscore XY to show us that this is actually a projected coordinate system. So this how to able to name your grids very well. Then the grid cell size, if you click on this question mark, click on this question mark. The grid cell size, you see, is recommended to be 1/2 the flight line spacing, right? 1/4, one quarter to half. So for this data, the flight line spacing is 500. So it depends if you are doing ground, whatsoever. You also try to take note of the same idea of what you do. Since it's 500, I would say 500 divide by 12 calculator. The flight line spacing is 500. Divide by, I have to take 2, then I have 250. You can divide by 4, that is 125. Or let me divide by 2, I have 250. Remember, this is 250. Then click on OK. It's very important so that you know it. Then click, or you can leave it empty, but just click it OK. So it takes some few seconds to now grade our TMI. Now you see this is our TMI, which we have. Then go back to the database. Now we are going to switch the coordinate to longitude, latitude, and plot. There will say coordinate, now set coordinate. Now for the eastern is longitude, for the northern is latitude, then the third value Z. And now you see it has switched over them. Then we say grade, grading, minimum curvature. Now the same thing, I'll call it LL lat long. This time around, you need to remove this one because this one is not used for calculation. It's not the projected. So leave the grid cell size empty when you are geographic. Then click OK. So I want us to look at some of the things because my so wait for some second for you to grade it. So please, a question. If you have a question, you can ask, please. I think I can off the MV software for now. So far, I don't need software for now. So that I can free up some spaces. So let it load. So let's refresh. Refresh. Let me close the PowerPoint. Station. Let me, okay. So let's wait. It will take some few seconds to project it to the geographic. So let's see delay. What is causing the delay? Let me close this one. So let me refresh. It's taking time. So now what I'll do, I'll go to this. Now go to our gravity. Let's go back to our gravity data. I will get our gravity data. They will come here. So this is where we get our, let me minimize. This is where we get our gravity data. Starlight gravity data. They will scroll down to where we have regular grids. So under these regular grids, we have the long time model, the most widely used EGM207. You can read much about it here. Select the long time model. Then these are the functional selection. You can set the Bouguer anomaly. See it here. The simple Bouguer anomaly is defined where the corrections has been done. The Bouguer correction has been done. The topographic also has been done. Some of the other corrections has also been done. That's what we'll be using here. Select this one, Bouguer, select the model, then come here, then for the location. Open our text file. We're going to input this value. Longitude is 5, the minimum. Then the maximum latitude, longitude, then from this side. So you can see there, then we'll go back, minimum latitude. Then this, then we go back to this one. As you can see there. Then now, this is the grid step sizing, which is in degree. If we do in minute, that will give us, if we divide minute, if we're going to use interval of 1 minute, that is divide minute to degree, 1 divided by 60. That gives me this. If we're going to use 1 seconds, that is 1 divided by 3600. I have this, which is 400 something. So what I do normally do is to say 0, which I have before, 0. So you can see here, this is the value. This is 1 second. So the size, the more grid step of 1 second, arc second, 1 arc second, which is that is 1 divided by 60 times 60. Let's give you this. And this all you need, the model, AGM, the Bouguer. Location is this. They leave everything at the WGS 84, then click on Start Computing. This will process it and allow you to download. Once it's there, let's move back to our Oasis Montaj. So what is happening? It is delaying. I don't know the main problem. Okay, now let's go back to our browser. Let's go back to our browser. It's now processing. As you can see, it's doing a lot of the corrections there. Then you see about 709,000 in rate points. Okay, wait it for 50 seconds to finish. That will give us a link for us to download as our gravity data. This is the Bouguer anomaly. It take 1 minute or 1 seconds to go. This is how you download the gravity data. Is AGM204 gravity anomaly Bouguer. About this is that number of data points we have. The more better the resolution. So now let's go back to this. I think from here I can cancel this one. Let me cancel it. Let me create Read again. Then let's see. Okay. So let's see whether the gravity data has been calculated. It's been done. It's still downloading. We have to wait for it to download. We'll get our gravity data. I think let not waste time here. Project save. Let us switch back to projected. We don't have to waste time on this. So this is what we have. Okay, now file project save. Then go back to this. Can now reproject it. Then reproject this. Is another way of bypassing it. So project it's already projected. And now we call it TMI. That long. Next. Then geographic. That's all. Yes. Now you see this is a geographic. You can have a look down here. As you can see, this degree. So if we go to this is in meters. We can get the length in meters of this one by going by this right click. We'll come down to ruler. We have ruler. I click on ruler. The pointer change. You're going to look down here. Select starting point. Look very well. You click at the beginning, roughly. So this is a rough. We're going to do a better way of doing it. Click. Move your mouse pointer to the end. Then click. Then right click. Then select done. So when you check, what do you see? You see 84319. 84319. That is around 84.3 kilometers. If you go to this right click ruler, let's get the height. Click this point. Click this, right click, done. It's around 84 something. So if it is accurately, they are the same. It's a square grid, around 84 point something kilometers. So it's a very big size, kilometers. So that is the rough way of doing it. So now let's go back to this one. We'll see. We're going to push this one to Google Earth and ArcGIS for us to validate it. Then we'll click on this, map mode, then click on this. You see it has been selected in this form. All you need to do is to come to map. Then you have export. And that is export. You export it in two ways. You export it first as a key up markup for Google Earth. There you can leave the resolution. Let me put it around 200. You can see the file size unknown, full map, then click OK. Then go back a byte, go to Google Earth Pro, and call it TMI. Save. Then go back to map. We export this time around as Geotiff to push it to ArcGIS. Geotiff. Then I can take it to 250, but look at the size, it's 23. Let me put 200. Works okay. Then full map, then okay. Then now I'll go down to images. I'll put this one under images. I'll call it TMI, Geotiff, save. So now click outside, then you're okay, then click file, project, save. Now click for this, close all. Now we are able to get the TMI here. We'll leave that for the radiometric for not now. First, we'll have other data to get, of course. Okay, so maybe that's the time because it's recorded as but sometimes it does not take me a long time to do. It's a few seconds to take. It's just that the stem is hooking. That is the problem. But that is the way out to do it. Let's go to our gravity data. You see it has done. Then click on results. So this, you click on results. Click on result. Then on the result, you can see the gravity data is coming up here. You can have a look at it when it's loading. You can see the area of what the gravity is. Then come down to this. You see the format. You download this one, software 7 grade 57 megabyte. You click to download. You see it's downloading now. So while it's downloading, let's minimize. Okay, let's minimize. Now we are going to go back to our folders, project, go back one lead, go to our Google Earth project. You see the TMI. This is the TMI I'm talking about. So this TMI, you double click on it, or you click, right click, open. This will take us to Google Earth. You see it? This is where Google Earth is. This is actually, you can see it has gone into Nigeria, and that is where the grid is. You can see it here is already projected. You see, this is the values. We will talk much about this. Let it load. So let's wait for some few seconds to load other things. Let's put roads, places. So you see, this has been loaded. So let's give it some few seconds to load out those other things. To load, so this is where it is on the ArcMap. If you check, this is part of Africa. This here in Nigeria, and that is where it is. There, then we have seen this data. Then now we need now to open ArcGIS. Now under the ArcGIS, we need to come back to this point, add data. Click on this to connect. You just come to add data. Click to this arrow, add data. Then add data, you come down to the connect to the folder. Then that folder will connect to Quara states. So I've selected the main folder and click open. Then now under share files, double click Nigeria. Now we'll take the first one. Now click OK. So this is Nigeria is loading. So this Nigeria is loading now. Okay, double click on this. Follow, then leave it. Okay, this is the part. Let's put those marks and put the Quara state. This is the Quara state. Let's double click on it. Double click on this one. So there we'll label these features. We'll give it a name one. I think it's around name one. When you look at the attribute table, apply, then okay. See, this is the one. This is a Quara state. So open, right click, open attribute table. We'll go to name one. Why is name one? This place Quara state. This Quara state. You see, you minimize. Going back. has been selected, then right click, export data. Then this, they'll go to our share files. We have to go back to our main one, Quara state. Then under share file, they will call it a folder. Call it, no, there's no need. Let me just leave it. Then I'll call it Quara state. Quara state. Okay, just name it there. It has been done. Then click OK. So now this is the one. So click on this one. Olo outline. Then the outline color, I'll give it green. Now you can see this is the one we have. Now let's come to this, add data. Let's add that Geotiff import from Oasis Montaj. Go to this project, images. Now this is Geotiff, you add. Yes. I see, you can see it now. This is where we have it. You see it? This was part of Quara state where the data is, the 4 sheets are taken, and this is the one we have. Okay, we can come here now and save this, save. So we can work on it, then go to desktop first, go to Quara state. So we can come to it and work to it later. Let me see. Quara state and ArcGIS project. Okay, let me create a project. ArcGIS project. Put Quara state. So this is what we have, then save. So we have saved it. Now we have the project, we can come back to it and do other things. We can off that of Nigeria, which we have. We can now click on this, right click, zoom to layer, which you can see. This is what we have, then click save, then minimize. Okay, so I hope everybody is following. Now let's go back to our downloads. You see a lot of softwares. We are doing, I think download has finished. Right click on this folder. It's a folder now that I'll put F2, rename it to gravity data. So this is what we have. Then this, copy from here, go to our folder, go to this Oasis Montaj project, go to data, gravity. Now you see I already have gravity data. So right width is 56. I'll click on this to override. Yes. You see it's still around the same size. So this is how the data is got. So I'll go back to now finish with this one. Then I'll go finish with this. Then I'll go back to Oasis Montaj. Now this, remove this one. Go to this, add grids. This is a software grid. First go to data, gravity, then select the gravity, then change this one to software. So you don't get error. Then click open. This is the what? This is the data is already in geographic. So we can come to grid and image, utilities, save grid to database. Now that is this. A database, I'll call it the Bouguer anomaly or gravity. Gravity. Looks like that's all. So it's just for us to get the data, not for you to process it yet. To get the data, I'll get the database. That's all. So come to this, we remove from the project, we go to the database, which is this. Of course, this geographic, edit, I'll give it 3 place of decimal. Edit, 3 place of decimal. Then now this, I'll edit, I'll call this one long. This, that. I'll click on this. No, then click on this, right click, insert column, click, right click, insert column. And from here, I'll call it new X. I want to do a projected. Right click, new Y. And that's where we have. Then now let's, because if we click on this, right click on the gravity, it's not being projected. You see it's unknown. Then we'll call the coordinate system first. Coordinate system, it should be in geographic first. Now it has been projected. It's already in geographic now. We have set in geographic. Then now let's project it to XY. Then coordinate system, new projected coordinate system. Now we need to change to longitude, latitude. It's also in geographic. Okay. The next is to change now to X, latitude to Y. Then click projected, use the UTM 32° north. It has come. Then click OK. So let's see how it is done. Okay, now I see it has come. Okay, so this will come to file, project, save. So this is the gravity data we have. We can switch over this. Now coordinate. Coordinate, set coordinate now to long lat. And now probably grade an image, grading the minimum curvature. Channel to grade now we'll call the Bouguer anomaly. Then lat long. Then let's give the sum. So it's now open it. Because remember the points are many. So that's why it will take some few seconds for it to load. It takes some time because I'm recording it. So you have to take note. It will soon finish it up. So while it's there, let's come to our study area now. Five and the other one. Please let me cancel it. I've already canceled it. I've already canceled the project save because we're not yet to process the gravity data. We'll come back to that later. The project save. I think this is how to get the gravity data as well as the magnetic data. We have the database. So we're going to be working with this. This is a Bouguer anomaly. And this is the data of the total magnetic intensity. So project close all. And now we'll close the Oasis Montaj software. Then we'll come back to this particular man. I take the minimum longitude, maximum longitude, maximum minimum. Then I'm going to combine them with this man. I will take this with this with this, then this with this, then this with this. So that this first one will be 8. This one will be 8. Then this third one will be this values, which I'll put here, put here. So this how to do this minimum this, minimum that. So please, sorry, I have back a power. Now I'm back. Okay, so we're going to see it was having an issue of power failure, but now I'm now have some charge for us to. So please, if you can hear me, you can just write yes. If you can actually hear me, you can please write yes in the comment section. What I do, the minimum longitude, maximum longitude, maximum longitude, minimum longitude. This is the minimum latitude, minimum longitude. So that's how you do it. Then you click save. You'll see what we are going to do. Then go to desktop. Under desktop, go to our state. Go to our, we can put this anywhere we want it to be. Let's put it under the data. Then come to this comma separated, delimited. You call it OD area. Okay, we want to use it to get our Landsat data study area. Then click save. You see now it has been in this format. See it? That will be X, Y. Right? You know the X is for the longitude, the Y is for the latitude. Then close. So please, you can type yes if you can hear me. So please, can you all hear me? So now let's see, we have this as our, so we have this data. Hello, if there's anybody can hear me, so let me see. Can you all hear me? Okay, so I think everybody is now hearing me. So now let's move to, let me move to ArcGIS. Now let me move to the ArcGIS. So let me off this area first. Let me off them. I'm now in ArcGIS. I want to bring that study area to create square area, which can I use to get our Landsat data. Then so now what we are going to do, we go to File, Add Data, Add XY Data. That is the method you do to bring out the CSV file. Under this, what you choose, you click on this folder. Then you go back one more. To go back outside, you click on Data. You see this is the study area CSV, then Add. Then you see the coordinate system is this, but you can click on this, Edit. You select it, or you can come over this and select your coordinate system here. I have my own WGS 1984, then click OK. Then here, OK, then click OK. You see, this is the point. See that? Now we're going to change this one now to a polygon. We have 3 steps to do that. We'll click on this Arc toolbox. They'll come to Data Management Tools. They'll come to Features. They'll write feature to point first, the first value, feature to point. And what is that? This is this study area CSV event. Click on this and sit here. So I hope you all can hear me well. So click on OK. So where there is going to load it. So it's going to change it first to point. It has done, you see it. Then click on the second one, you remove this one. We don't need it. Go back to this. Then go back to Arc Toolbox. Then now the second point is point to line. What is this point? This is a point. Select it from here, which is this. Then you click on this close line option. It's very important. Click on this, then click OK. Right? Then now you see this is the line. Then this one is a point we don't need it to remove. Then now go to Arc Toolbox again. Finally, feature to polygon. That is this line. Select this one. It is this. Then now leave everything. Then click OK. Now you see it here. Then we'll right click on this, remove. Then this one, we'll right click. Then we'll data, export data. Leave everything. Then click on this, so the location. Then we have to go back to our share files. Our shell files. Now we'll call it the study area. Study area. This is what we have. Then click save. Okay. Yes, we have added to the map. Okay, this is a study area. We don't need this one now. Remove. Now click on this. Click this. Increase the size of 2. Give it a color of red. Then okay. Then now bring our Quora state. You can see it. Bring our TMI. You can see it. TMI. We are now finally able to get it. You can see it now. So this is how we get the study area. So let's see if there is a question. So please, if you have a question, you can ask. Like I said, you want to get the area, right? We have first done one part of the ArcGIS. We'll see how to get this man. Yeah, this is the area which you will not be using to get the Landsat data. But let's get the area first. Let me off this one. This is the one. Right. Let me right click or zoom to layer. See, this is the layer. We want to get the area of this size. We need to do that to go back to our toolbox. Click on this. Under database management tools, come down to projections and transformations. Come to project. Click on this one. Then click the input file, which is the study area, and sit here. Then here the coordinate system will change it now to projected. Come to projected coordinate system. UTM is in the WGS 1984. in its northern hemisphere, 32 degree north. This value, then click OK, then click OK. Now it's going to project it. Now you see it here. So now we off this one, right click, data, we're going to export this data, and click on this field, and now we'll call it to the area XY, projected XY, save. Okay, so yes. Now this, let me off this one, let me let me give it a color of blue. Now this is the projected, it's in meters. Let's confirm, right? Double click on it. When we double click, go to source, you can see it's in WG94 for UTM zone 32 degree, and it's already in meter. Because it's already in meter, and that's what we have. Because it's already in meters. Please, coming back, give me 2 minutes. Okay. So please, I'm back. Let me see whether is there anybody that have a question to ask? Is there anybody have a question to ask? Please, anybody have a question to ask? Let's see whether you have a question to ask. So let's go back to this. Now this is study area in XY, which we have. Now let's get the area, right click, open attribute table. And I see this is the area. You see it? The study area, you click, right click, you copy, then you close, then go back to your Excel software. So now under the Excel, we have our area. This is in meter square. Click and paste. So this is the value. We have the area. The area is going to be, this is now going to be in kilometer square. That means we are going to divide this value, going to equals to this value, divide by 1 million, 10 to the power of 6, that is 1 million. You can see this is the value. So this is what we have. We take the dimension, that is square root of this one. It's going to become SQRT of this value, which is, consists what we have actually, which is around 84 kilometers. You see? So this is the area which we copy, come here and call area. The area is this square kilometers. Then the dimension is this value. Control C. Dimension is this value by the other value, which you put it into 1 decimal place, 7 kilometer. Ranges from this longitude to this latitude to this, which you can convert to degree and minute. Control save. This is the area of the study area, 7,002 square kilometers of 83.7 by 83.7, roughly is a square. So close, we don't need this one again, then close, don't save. So please, do you have a question to ask? So is there anybody that have a question to ask? So please, you can ask a question. If you ask, so this is how to get this, then we'll right click, remove this one. And now study area, remove this, we don't need this. Now this is the quarter state, and which you can bring our TMI, which is this, you can see it. It's not our TMI, which you can bring. So this, you can see it. If we bring the TMI there, it's going to perfectly fit inside. And what we see, click on save. Now we have to go back and now export this as KMZ in Google Earth and see what we're going to do. What we do, we'll go back to this Arc toolbox, they'll come to this conversion tools. Then we'll say to KML, that is Google Earth, Google Makeup Language, to layer to KML. Which layer is that? Study area. Then they set the location and go back to our desktop, the project, Quara State, Google Earth Pro. This time around, we call it study area. So click save. Now you see it has been done, then okay. Everything has been done, then we'll minimize. We'll go back to our folder. Go back to our folders where we have Google Earth Pro. Now we have two. This is the study area. Double click on this. This will take you to the point. You can see it now. It has fits perfectly well. Right? It has fit. So it has put. So you see that the places, I don't know the reason why they are not coming. Okay. So this is the actual area which you can see if I off it. I have the study area. If I bring it back, it fill up. You can see it both on the Google Earth and the rest. So these are important way of able to look at our data. Now this is how we get, thank you, somebody from India. Okay, now let's see how do we now go back to our Landsat data. We'll go to the Google Earth, earthexplorer.ug.gov. This will allow us to get our Landsat data. So you need to sign in, provide your credentials for you to download. I've already have an account. When you log in, you'll be taken to this site, this link. It's there in the description. What you do here, you first come to KML or shapefile uploaded. Click on this, then select file. We'll go back to where we save it, Quara State, Google Earth Pro. Now it's a study area. Then click open. It's going to open it up here for us to see. So if you have not, let's let it back. Sometimes there is a bug there, open it. Sometimes I used to open, let me refresh. Get the file. This, open it. Let me select, let me see, select this one, study area. Maybe it's open here, so maybe we need to close it here from here. Then let me go back. So we need to close it from there. So that's the reason why it's showing this error, because it is being used there. Then this select file, study area. Now you see it, so close. You see it now, this is the study area. So this is where we're going to now, it has already select the area where we need our data. The next thing to do, now we'll come down to next range. You can leave the data range like this. Cloud cover, I can bring it out to 3% of cloud cover, around 3%. So it's okay. Then next, you come to data sets. Now, of course, we need Landsat. Is a Landsat. When you have on that Landsat, you need to do collection 2, level 1. This one worked perfectly. Level 1. Not level 2. Then you select the first one, Landsat 8 to 9. Click on this. Then finally, you come down. Result. Let it load. Search for those data we need. I see it has loaded them, many of them, up to the last one of 9, up to the last one. What we need to do is to look at those who are covered this. We'll click on it, which is a footprint. This is the metadata, the time the data was collected, acquire the path row, and the path, and then the row. Then click on this to show you a footprint. You see it has not covered it, so we don't need this one. We're off it. Click the next one. It does not cover all. They'll move the next one. You see it has covered. So this one has actually covered. All you need to do, you have more option here. Compare this. You have the show metadata and browse download option. So you click on this download option. So you see when you reach here, you click on this. Now you see the file size is 1. So when you download this, you get all this information there, which you have band 1, band 2, band 3, band 4, band 7, 8, 10, up to 11. It's a data you get to download. When you click on this download, the download will start. Let me click download. But see, I've done it before, so I'm going to cancel it. I've downloaded before, but I'll cancel it. So this is what you have here. If you open the Quora state, you go to the data, Landsat, you can see this is the one that I downloaded. You see the size, the same size. So these are all the bands. You see them? So those are the ones we need up. So that's how to download it. Now let's go back to get the metadata. You click on this. In case you want to get the time data was collected, you click on this, show metadata and browse. You see it? So this is the data you have. All right, so you can, this give you the information of the data. The date it was acquired, the collection number, the path rule, which you can use in your research work. In case you want to know, you can save it. The date was acquired, the start time, and other informations are here, which you can include in your work. This is how to get the metadata of where the data was collected. So this is what you have, how to get this data. Now the same thing, if you want to get the digital elevation, which you will see not today, But the same way, you can go back to data set. You have this one, they go back to this. You go to digital elevation. They come to SRTM, 1 arc second, just like what we do under gravity, which is 1 arc second. Then we click on result. Let's see whether we can get this one. It's searching. So now we have so many of them. So we need to look the footprint. No, this one will not take us there. No, no there. Sometimes you need to, this Gabon, actually it's not actually the area. So sometimes you need to go back and then do it from the scratch so that you can able to get yours. Just like you need to upload those study area here for you to have, but then leave it for now. Now we have the data is available. What is this? Now we need to go up to MV software, which is the one that we use analysis. A target is just to see how to get those data, see them coming properly. So we start the analysis. So we get all those data we required. So I think for now, we don't need this one again for now. So everything now is in line. That will close for now. So let this one load. So let it load. So like any question? So any question? Yeah, we're not starting, we just want to import it to see that actually we're getting the data we want and close. Then this is envy. It's going to be very simple when we come to remote sensing analysis. We use much of this one, the Ban algebra, the Mosaic, radiometric corrections, and some other things which you will do here. The principal component analysis, all of them, we'll see them here. Then let's come to file, open as optical sensor, then come down to Landsat. This is the method of open Landsat data. Optical file, open as optical sensor, Landsat, Geophysical with metadata. From this, we'll go back to our desktop, Quara state, our data, Landsat, which is this. Double click on it. It's going to open the metadata, which have the information. Click on open. So this error is going to happen. When you see this error, it's very simple. What you do, you just go out here, which you open this one, look for the metadata, which is this. So this is the one that ends with .txl. This is the metadata. You open it, you see it. You see this is the metadata, which you will see. Okay, this is the metadata. Then all you need to do is to remove this one and write 1. Then save. Everything is going to work now. Then come back and then open NV software. File, open as optical sensor, Landsat, Geophysical with metadata. Then now click this one, open. Now you see it. This is what we have. Then click on this, zoom to full extent. This is what we have. Click on this to pan it. Okay, improve the construct. Many things here can be done. Okay, reset back. Can do so many things. Linear 2, change the layout, change it linear 5, change the way we want to view it. And then the logarithmic, lot of changes, but can leave it up to linear. Okay, so this is how to load the data. Download, of course, is not all. We use only the part of the data we require. This is the remote sensor covering over the areas and its environs. So this is how it is. When we come to remote sensing, we're going to be working with this to tell you how to import, how to download it, and how to bring it to MV software, which you're going to be using, then close. Yes. So we don't need to save this one. So it has begun. So now let's this. So please, does anybody have question? So anybody have question to ask? So please, if you have a question to ask, then you can go ahead. Now let's see. Now we have got our this data, remote sense data. We have got the gravity data. So now let's go with that of the open the Oasis Montaj. We have the radiometrics one that we need to bring in and have everything set, and also the one that we need. So let it load and let's open our Oasis Montaj software. So this is our so let's look for a project. Open project, desktop, Parastate, OS projects, free training. Okay. So we have this here ready. So the next thing we need to do now is let's go to the database gravity. Now let's switch coordinate to XY first, then coordinate, set coordinate, X, then Y. Okay. Now right click, properties. Okay. Now let's grade it. So then now we have the Bouguer anomaly XY 250. Grade cell size 500 divided by 2. Then we have this. So this is the one we have. Then the next thing, let's reproject this grid. Now Bouguer, which is already projected. Okay, then now in geographic, PA. Yes. Then geographic, okay. Finish. Now this is what we have. This now is our gravity data. Then select this one, map mode, then click on it, then go to map, export. Geotiff, the same location where we saved the other one. Under images, now we'll call it BA. Save, then go back to this into Google Earth. Now, once open, let me open ArcGis. Then change it to key up makeup language. Okay, then click OK. Go back, Google Earth Pro, then now VA. Then click on this, click outside, file project, save. Then let me remove this one. Project. Target, we now have the bouquet, we have this. We have the Lancer data. Now let's validate this. Now let me open Google Earth and validate that the two, the TMI and the BA, we are the same area covered. Okay, so this was a TMI. Now let me go open that folder. Google Earth Pro. Then this is the bouquet anomaly. Open it. See, it has taken us there. You see the same location. See, so this is the same location. I can off it from here. You see it? I can off the TMI. Now the times has come. The TMI is there. Now this is the bouquet. This is the TMI. This is the study area. This is the study area. This is the bouquet. This is the TMI. So you see the data are all from the same location. So this is that how you look at it. You can off it and have a look of these features. You look down, down, down. Let's say you need this area. You can go down, down this location. You can zoom down. So it will take some time to see the areas of features you want to take. You want to download it, you can come over this, high resolution, save image, can layout, you can remove all these legend, you don't need them. Resolution, you can change this to 8K, onto something like this. So you save image. You can call it AW1, query state, then let it save on the desktop. So it's going to load out there. So in case, so this is how to look at point and then zoom out and take image of high quality, because if you take high size, it becomes larger in size. So if you zoom, you see the quality. So this is, well, let it load. So you are able to look and see the area where you are, what you want to do. So you see, you can now zoom back and zoom out, take you to the area, you drag, then you bring back your bouquet, you bring your TMI, the same location. Now let's open the ArcGIS. I think we already opened the recent. Let's open it. Just to validate the GIS. Now you see it. Now let's come to add data. It's on the go back. File project, images, then bouquet. Yes. You see the same location. You see them? We have the bouquet, the TMI, the same location. So everything is working properly well. We have the same location. Now I remain the radiometric to validate them. And that is what actually I've done here. Able to validate them. So this is the bouquet, gravity data, this is the magnetic. So this is what we have. So any question, if there's anybody have a question to ask, so the person is free to ask a question. So let's see whether there's anybody that have a question to ask. Lastly, let's go into, now window close all. Now let's come to the grids. Now we need to repeat the whole process. Now we come to data. Now the radiometric of 3. Each of the sheets, we have potassium. We'll take potassium from this. We'll go to the next one, we'll take potassium from this. And also later we merge them as one database to have potassium TMI. They will do the same thing for thorium, right? So let me open it first. Project, go to grids. I'll first take the first one. Radiometric, go to the first one, potassium. So this is a potassium. Then go to utilities, save to database. This is a potassium. And how do you name this one? It's potassium 203. P means potassium, sheet 203. Then Z is easy to identify. So this is remove this one. Now you see we have potassium 203. We do the same thing, add grade, then go to the data, radiometric, then 204 potassium base. Then this, go to this, utilities, save grade to database. Then now this is potassium, we name this one 204. Then you are good to go. Okay, we have this. Then now remove this. Then add this. Radiometric, that the third one, 224. Potassium. Utilities, save grade to database. For the 224. Then potassium. Then we have this. Then remove this. Then the last one for the potassium, radiometric. Then the last one, then potassium ethers. Then we have this grid and image utilities, save grid to database. Then now we'll call it 225. We'll set the output to this, then this. So the output has been set to this. Now the next thing, now remove, we'll do the same thing for the other ones, for thorium. For the other ones we have, because we had the grids, we have the other ones. The domestics for T3 we do for thorium and uranium, the same process. So now let's first start with 203. We need to project, we set the coordinate system, which is projected. So okay, they'll come to the next one. Coordinate system, projected. Okay. Well, coordinate system. Two, 225. Coordinate system. Okay, now let's double click, cross check. It's okay. Let's cross check. Okay. Coordinate system. Let's cross check to be sure everything works fine. Okay, now we're going to merge them. Those will be the other time database tools, utilities, merge database. Now this time around we have PO3. Then this we're going to select them. Select PO3, hold down your control, select the next, click, select the next. So we're going to add 2, 4, 2, and 5. Then all lines display append. Then click OK. Let's see whether there will be error. There will be error. Let's see. You see it has exceeded. So we need to grow it. So let's click on this one. Database, maintenance, grow. EO3. Yes. I'll change this one to 3000 to work. Then repeat back the process. Utilities, merge database. All our assets, PO 24224 Okay. Okay, so we don't need this one. Hold control key or control key, remove this one from project. This is potassium and this O3. Okay, this potassium now we have. So we can click on it, click so that we can edit it. So can I put P? Okay, yes. You're right. Okay, maybe you can leave it like this. I want to change the name, but there's no need to change the name here. So P is for potassium. There we need to take grade course. Let's cross check properties. Okay, now we grading. Then we go to grade it. This one we call it potassium XY. Of course, we don't need this grid size. In this case, we don't need it. Then click OK for potassium. We can call it rad radiometric. So to identify now this is what we have. So it's going to grade that of potassium. So any question? Any further question? So let it take some few seconds for it to load. So let it load and see what we are going to get. Because the data is huge, that's why it takes some time to finish it up. Somebody is asking, how can we overlay one map over the other using ArcGIS? So don't worry, we'll do all that one here. You are just starting yet. We'll do more than that. So leave it recorded, of course. We're going to leave it recorded for you to have. Okay? We're going to have it recorded for you. A lot of things we can do with ArcGIS. We're first trying to get the data first. All the first set of data we need. So we're not taking them one after the other. We try to see how to use the ArcGIS in own parts and all of them. Of course, we're not just started using the Qgis and the software. We have seen how to use the MV software. We have just seen what to, so like I said, the data are large. So you have to take note of it because if you check the file size, that's how normally they are. So you have to be a little bit patient. Look on the data, ionometric, look at the potassium. It's roughly 6 megabytes. So it does have to. So you see, you just have to be patient and so that we can able to finish it up. So it will take some time to up. So now before we do that, we need to first get our maps are talking about. Now we'll open this map, QGIS. Now we're going to work with our geological map. Okay, which one of them is the lineament map first? We need to go about how to do. We're looking at how to go about data, but just to show set up, we need to set up everything before. So that will be that one where we go to produce the lineament so that one will try to make it reference to the geological map of etc. etc. That's loaded. So can give us it will take some time when you try to merge it, but one and start do the analysis. Is sometimes that is how the problem is. QGIS, all you need to do come to layer. Yeah, it's better to do it here. I prefer to do it in this base source. Not raster, we have vector, then click on these three dots. Desktop, water state. Narrow it out to two, you hold the control key. Then you add to Nigeria. Then add, then close. Now Nigeria, you drag it down. And click on this question mark to check. Click on this question mark. On this Create a map to this. Then double click on simple fill type, no brush, apply it. Simple fill, solid, no brush. Increase 1 to 3. And apply it, okay. Then this one, no brush. This, then apply it, okay, which you can see here. Because the reason is they will save this one. What I'm doing here, back to my desktop, Quadra state, lineament. No, let us call it lineament. Our lineament here under the save. Let's click, right click, right click, layer is correct. Layer, everything is set. Now we're going to do what is called code. Sometimes, but we have to give some time to grade it and come back to up. But what in it, that's why data is huge. Refresh, and let's go back to layer. Now, to take out this file, this lineament map, you see, and put out where the fault and the rest. We'll try to locate where it is, very state. If you look, this is the point. You see the point? This is the Quadra state of it goes like this. If you have like this, just over it, you see shape. So this is the shape of the Quadra state. We want to do reference. That we can able to get all those lineament map from the geological map comprehensively. That is any of area you can get it. How do you do it? Our GeoRaster. Anybody have any question? Question. Let's go back to this. Raster. This to add it, the open raster. Quadra state data. Why is this data linked? So you see it has open. Then you come under set linear nearest neighbor, then select on this to set the location. From under Quadra state, I will leave it under data, lineament of stage first, so the format is okay. Everything is up. Zoom out and see the area where we have area. So what we are going to georeference means with what we have here. With the other one we have. Because we try to look, this is the beginning point. State, you see it. It goes like this, goes like one of it. Shape. I use GIS. Once you are set, you are able to zoom, you are clear how it goes. So I will link this point to this point. How do you do? It's already selected. At the point you click on point, this one will show up. Then from the map come that point. This is the point. You select on it. Selected, you see, then click OK. You can see a dot, this point. Click on it from map canvas, then OK. The next thing is to come to this point where it touches this and click on this from map canvas. Then OK, you see we have the next one is to come to this point down here. At least 5 or 6 points is over. This point, see here, is the point. Then OK. Edge, I think I need this edge. I can have a screenshot of it. So somewhere here. Okay. I'll play this point. Okay, so I can see I have 1, 2, 3 point will be okay. So all the 6 point, and I have about 6 point. We have 1, 2, 6 point that actually correspond on this. Start your referencing. Goes to start. Nice doing it. Can see it here. This, then okay. Then I will drag it very well. You see it. Let me put off Nigeria. See it now. If I off this, you see it. And I bring it. Follow that shape. This is green color. You can see approximately. See, you're able to get it. Your reference, but even though this one is not because our study area one, yeah, we can see it as what we have. Then since why, yeah, we'll go to study area, right click, lineament, and within those study areas, we will now create. So this is what we need. This is actually being georeference. You see the public correlation because it passes exactly. Of course, we can now free to reference. Let's see if there's anybody have question. It's still loading. So it will take some time to load. So sometimes that is how it is to be. Here we are. This is the radiometric one for what? Which we have. Project utilities, reproject grids, potassium, right? Potassium, next, graphic, then this. So now let's give you some few seconds again. Potassium concentration over the study area. And now go back to our any question. So like I said, now let's go back to Qgis. Digitize now. Now let me off the quadrat state. Well, go and redraw. I have to go to layer, create 3 dots, then go to desktop, quadrat state. So this is the lineament. Geology. Geology. From the geology, here we is line. Of course, right click, layer is unknown, set. I'll click this, it's okay. Now the layer is, you see, is this. So this is what we have. Click on this arrow, toggle editing. And now we're going to give it a color. Double click first on it. Set the line. A color, I'll give the color to be red. Apply, okay, so that I can design it. Arrow, add line features. Then you click, then you click OK. See, I have this point. The next one, click, left click, right click when done. Click, right click when done. Click, left click, right click. Click, left click, right click when click, right click when done. You click, right click, done. Click, left click, right click, right click, done. Click, left click, left click, right click, left click, right click, done. Left click, right click, done. Click, left click, right click, done. So this is the way. Left click, right click, done. Click, left click, left click, right click, done. Done. Click, left click, right click. Click, left click, right click, done. Done. click, left click, right click, done. Click, left click, right click, done. Left click, right click, done. Right click, done. Click, left click, right click, click, left click, right click, done. Done. Click, left click, right click, done. I think click this. Is what we have. Then this man. Click, left click, right click. I think these are what we have. Another one, left click. Click, done. Everything is nice. Okay, another one. Okay, everything is okay. Then done. Then we'll click on this and click save. Then another we are. We'll area zoom to layer. Then now we'll click this to black. This is a lineament. We have image. The areas. So those are the mini ones. You can see major four. You can see that this was what actually we have. Actually, with any question. So anybody with question, or they say we have, which we have. Then the same thing, we'll select this one, export, key of makeup language, okay. Google Ads Pro, Radian. Okay, we have set up export, Geotiff, full map, of images, potassium, RAD. Click on this, click outside, file projects. Now we have this as our, so the same process we use to do that for the thorium and uranium. 3 radium, potassium. Now let's validate this in our ArcGIS. Now this, then okay. Same location. This is the potassium. This is the TMI. All the three data is in the same. Able to have them and able to validate. We'll see it. But for the Landsat, before we're able to extract it. By the way, it has been done, and that is the best way of doing it. Potassium 1, Bourget anomaly, and save project. So at the end of the all to have a look at them. So this is how to validate that all the data are within the same place. And this is what we have. So that of the other ones. This is the way you do the other one. Add grids. Radiometric. Open. Save to. Now this is 203. So it says that you come here, add grids, data for Thorium is empty. Then grid and image utility base. Thorium. You see the idea is the same. Thorium this for 204, you do for 2, and then you combine them, we have one. We have the thorium now able to go to place. Does anybody have a question to ask? Let's see. Let's see. Then data, radiometric, thorium, data image utilities. Play this one. 4. Then okay. This grade, we don't need it. Remove it. Then the last grade we add is 225 thorium. Is utilities 225. Okay. Okay, so we have this. Now the same idea, I'll click this maintenance grow thorium to grow it. Yes. Then place 3000, increase it. Now we need to go to database tools, utility thorium 203, and click on this. Select these 3. All displays append thorium. So it has merged them as one. So this is what we have. Name curvature. Y, then rad. So let it load. I think this is, let it load there. This is what we have for the lineament geological map, but for us to have it in line, X, we'll be using this one mostly in the aeromagnetic, where we extract lineament. Now have the structural map of the study area, also that of the gravity. We extract, we use that of the remote sensing lineament map of the area of the object, so showing in all, able to do this one. Bring this 3, 1, 2, 3. They'll call it element, so it's about it. You can come here and add and bring this one. Not been done. You come here, change those that have not. By clicking on this, then click on this. For now, let us go back and apply it. OK. The denominator we get from area and how this one is produced. We'll be making use of this in reference. We close this one. Please, if you have any question, let me see. So anybody with question? If you have any question to ask, you know, yeah, two of them will know that yes, them and do other things. So after getting the thorium up, after we get the thorium, stop, and when we come in the next day, the raw magnetic, the later we link it up with the remote sensing, up to the gravity, then we link it up to radiometrics. So those are the ones we need to do. So we know how to do. We have just here to validate our data, the potassium, the TMI, 3 zone we have, which we have seen. So we need this one again. So this one we want to create the study. We'll come to that. If you want to go back to any part of the world, this is the general Africa, Antarctica, Asia. Click on Africa. If you're in Asia, Africa, you select the area where you want one that will be used. The rest, select the zip format. So if I click on this format, you see it's 1.6. So this is how you get it if you are in Morocco. The size, file size. Okay, so that is the idea, but I've already done that of Nigeria, and that's what we're going to be using. When you have many things you can draw your study area. And also don't forget, if there is anything you want to come here and then do other things. Example, you can get in touch with me if you want. Has finished. Of course, thorium has finished. Depth. Thorium. Then geographic. So that will give us an how it is loaded, and this how all the. If there's any question, you all hear me? This and this port, Geotiff, Thorium, makeup, okay, PH, right, and that's Windows close all. So we see we have one, this one we remove them, TMI, uh, potassium. See this, I think that is so potassium, thorium, we remove it. This data we need. This is project save. Now back to ArcGis to validate. Bring to Arc. Now bring the thorium. See the same location now. This them. Our potassium. We are normally then TMI. Those all. So all the data are in Oasis Montaj. We have all the grids. Thorium, TMI, and other things, but I'm not able to. But I'll do that one later. So we have see how the data. I've looked for uranium. Uranium, the same process. Uranium, U. Press add grid. O4. Same procedure will follow before. So data 5 uranium. System projected. Coordinate system. Coordinate system. Coordinate system. Then we have this, then projected the same way. We will do it. Utilities. So let's first go to database. To 3 up to 500. Database tools, utilities, manage data 2, 3. Select the other ones. 2, 4. So okay, thank you very much. Now, I think it has finished loading. An image grading. So let it grade. So load. Yeah. So like that's what we have seen. We have the radium still loading, thorium, Fourier anomaly, and TMI. All our data. Vision. This, the other one, this, and the other one. Same. We have all the data in the same location. Finish. So now all these three, all this remove. All this one remove. We don't need it. The uranium, they will need to finish. So please don't forget to share it. Forget to inform them about okay, link is as finished. Map export. Google Earth. Google Earth. Oh, select this one. Export UT. Okay. You and that is you are good to go. Okay. Remove the gravity, the radiometrics, of them and the magnetic. So let's close all the windows. Minimize this, minimize this. We have done, so we can close the software, which you can close. It's already been closed. Let's go to add data. There will put the uranium. This, yes. Now you see this is the uranium. thorium, thorium, so these are all what we have, the radium. So this is what we have, radium, thorium. What we have for today, we're able to see date to cross check everything works. And then somebody is right, the magnetic and the radiometric uptake is from the aircraft. It's not satellite from aircraft. Device mount on them is an error. It's by aircraft. So they're not satellite data, aero data from device mount on the aircraft. Of course, satellite data and remote sensing is always satellite data. That's why we are integrating in order to be able to see how to integrate all of them. That's why we're doing this process. Thank you, Safe. Thank you very much. So the same time tomorrow, same time tomorrow, same tomorrow, same time tomorrow. May 19, 2024, 12 p.m. Central African. So thank you. So we are going to stop here today, and then it's going to be recorded, after which you can download it.